Hello everyone, welcome to another video. In this video, what we're going to focus on is how we add and subtract algebraic terms. But before you can add or subtract algebraic terms, you need to understand what we call like algebraic terms versus unlike algebraic terms, right? So we're going to look at like algebraic terms, right? So let's look at some examples. If you have some terms like a, 2a, minus 2a, 0.5a, negative 1.75a, quarter a, then these are considered to be like terms, right? Because they all have the same letter, right? They all have a, and the power of the a is the same, right? Despite the coefficient of each term are different, it doesn't affect the term being like or not. So that is not important. The most important thing is that the letters are the same and the powers of the letters are the same. Let's look at another example. Here we have 1, negative 2, negative 3 over 5, 0 0.5, negative 0 0.6, 7 over 8, and 3. These are like terms as well. Why? They are all constant terms. Despite some are whole numbers, some are fractions, some are negative, some are positive. They are all like terms. So all constant terms are like terms, right? Let's look at some more examples. Here we have 2b to the third power, negative 2b to the third power, 0.3b to the third power, 2 quarter b to the third power minus b to the third power, b to the third power. Yes, they are like terms. They are like terms because they have the same letter and the letter is raised to the same power, which is 3 in this case, right? So these are examples of like terms. Let's look at some more. Here we have xy squared, xy squared, xy squared, xy squared, xy squared. All of these are like terms. So note that all like terms can be combined and simplified to give one term. All right, so this is an important note that you should remember. All like terms can be combined and simplified to give one term. So let's look at some examples of unlike term, right? Now here we have a, 2b, minus 2c, 0.5x, negative 1.75y, quarter z. Now note that for each term we have different letters. So because we have different letters, they are not the same thing. They are unlike terms, right? Yes, the coefficients are very just the same, but the coefficients are not important. So the fact that the letters are different, then they are unlike terms. So let's look at some more examples. Here we have xy to the second power, xy to the first power, we have xy to the third power, we have xy to the fifth power, we have xy to the 10th power. Note here for each individual term, the power of y is different. So yes, these are unlike terms, right? Because the power is different. Let's look at some more examples. Here we have x squared, x to the third power, x to the fourth power, x to the fifth power, x to the sixth power. These are unlike terms. So despite the letter is x, but when you look at the degree of the power, they are different. They are not the same. So that makes it unlike terms, right? So that's the difference between like terms and unlike terms. You must look at the letter that is being used and the power of the letter to differentiate whether it is a like term or unlike term. All right. Note, unlike terms cannot be combined to give one term. Okay. So you must always remember that. Note, unlike term cannot be combined to give one term. All right. So now what we're going to do, we're going to look at how we simplify algebraic expression. Now that we know what are like terms and what are unlike terms, right? So you are given 5a plus 3a plus a, and you are asked to simplify this algebraic expression. Now, because they are all like terms, then this expression can be simplified to give one single term. Because if you look at the letter, we have a on each term, and the power of a is 1 in this case. So yes, it is like term, right? So what you're going to do is add up the coefficient and keep the same letter. So when you add 5 plus 3, that's going to give you 8, plus 1, that's going to give you 9. So when you simplify this, it's just going to be 9a, right? So what you do, add the coefficient of each term and keep the same letter. So you could put it in bracket like this here that I have. So it is 5 plus 3 plus 1, and put the a on the outside. When you add that up, that gives you 9a. So that's how you combine or simplified like terms, right? Let's look at a second example here. We have 15b minus 3b, and you are asked to simplify this. Then what is this equal to? You are going to subtract the coefficient of each term and keep the same letter. That's all, because first, when you look at it, they are all b terms, and the power of b is the same. So that means we can combine them to give one single term. So what you would have is 15 minus 3 and put the b on the outside, and 15 minus 3 will just give you 12 and put back your b, so your solution is 12b, right? Let's look at another example. Now we have 5a plus 3b minus a minus 2b. So note here that we're dealing with two different types of like term. So we're dealing with a terms that are like, and we're dealing with b terms that are like. So note that a color code here. So the like terms in this problem are 5a and minus a, and the other set of like terms are plus 3b and minus 2b. So how would you go about solving this problem? You could rewrite the problem by grouping the like terms, right? So put the like terms beside each other. So how would you represent this? You would just simply represent this as 5a minus a plus 3b minus 2b. There's something that you must really pay attention to when you're rewriting the problem. You have to pay attention to the sign that is in front of it, right? So as you can see, color coded here. At this stage now, you can do what? Combine the like terms to give one term, right? 5a minus a, that's just going to give us 4a, right? And we have a positive 3b minus 2b, that's just going to give us a positive 1b. So at this stage, you cannot simplify it any further because we have unlike terms. And remember, unlike terms cannot be combined to give one single term. There are two different things. So in other words, it's like we're saying that this 4a could represent 4 apples in real life, and this 1b could represent 1 banana in real life. So we can't put them together to give us one term, all right? Two different fruits. So thank you very much for watching, and do enjoy the rest of your day.